we're going to be looking at the last little bit with exponents, and we're going to round out the unit by looking at the identities. And there are two main identities we deal with when it comes to exponents. The first one is the zero power identity, and what that is that anything to the power 0 will equal 1. So if you look at the example I've drawn here, we have this really complicated looking bracket, and then at the end we just say the bracket is to the power 0. Well, anything to the power 0 equals 1. So it doesn't matter what is going on inside that bracket. We know that if I say the bracket is to the power 0, then the answer is 1. The next identity is about negative exponents. So when you have a whole number to a negative exponent, it's the same thing as taking the reciprocal. So we go 1 over, and then it's a positive exponent. If the number is already in the denominator and it has a negative exponent, we take the reciprocal, which means it becomes a numerator now, and now we have a positive exponent. If you're given a whole fraction that has a negative exponent, then you just take the reciprocal of the fraction. So we were x over y, now we become y over x, and there you can see we have changed the exponent to a positive exponent. So we're just going to do a few simple examples here. First one, we've got 4 to the negative 1. That becomes 1 over 4. 8 to the power 0 is just 1. Negative 2 to the power negative 3, that becomes 1 over negative 2 to the power 3, which becomes 1 over negative 8. But remember, when I was talking to you about math rules, in math, we don't put the exponent, we don't put a negative sign in the denominator, we put the negative sign in the numerator. So that's how you write a fraction properly. We don't say 1 over negative 8, we just say negative 1 over 8. So here now we have a fraction to a negative power, which means I can invert the fraction, but I don't need to take the negative with me. The negative can just stay there, and that becomes a positive fraction. And we can look at this simply as negative 3 over 2 times negative 3 over 2, which gives me 9 over 4. So I'm not going to write brackets there. So I'm just going to put here on the side so you can understand what the thinking was. This is the same, because remember, squaring means multiply by itself. So we multiply by itself. And then when we multiply fractions, we just multiply right across, which is how we get the 9 over 4. And here we have this really complex looking problem. Doesn't look like we can do anything with it, but we have power 0. That means the entire bracket equals 1. Now question F is a really important one to remember, because so many times we get confused and we start using rules that don't exist. So we have rules for same base division. We have rules for same base multiplication. We don't have a rule for same base addition. Remember, we've got the product rule for multiplication, the quotient rule for division. There is no addition rule. We need to work these out and then add them up. So 6 to the power 0 is 1. 6 to the power negative 2 becomes 1 over 6 squared. And that then gives me 1 plus 1 over 36, because 6 squared is 36. And then using my rule for adding fractions, we need to find the LCD. In this case, it's very simple. Our LCD is 36. And so we will have 36 plus 1 all over 36. And that's going to give us 37 over 36. I tell my students to leave things in improper fractions and not to give us mixed numbers. And also don't try to give me decimals either. So we're going to leave it in improper form. Another part of exponents is when we're working with exponents. And for that, I want to just bring your attention to a problem like this. It says write 32 cubed with a base of 2. So what this means is we're trying to figure out 2 to the power what is going to give me 32 cubed. That's what they mean. Okay? And the key is write 32 first with the base of 2. Well, 32 is 2 to the power 5. Okay? That means that 32 cubed is going to be 2 to the power 5 cubed, because 32 is 2 to the power 5. So where I see the 32, I replace it with 2 to the power 5. And now I can use my power rule, because when I take a power and I raise it to a power, I keep the base, so I write down my base of 2, and then I multiply those exponents, and I get 2 to the power 15. So let's look at this one. Write 81 squared with a base of 9. Well, 81 is 9 squared. So 81 squared becomes 9 squared squared. Okay, so I'm just going to highlight what were my equal terms. 81 is 9 squared. Okay, and now we have 9 squared squared. So write down the 9 and multiply those exponents. 2 times 2 is 4. Okay, write 100 to the power 15 with a base of 10. Well, 100 is 10 squared. So that's 100, and then to the power 15. So 100 to the power 15 is equal to 10 to the power, and then we go 2 times 15 is 30. And that explains how we got 100 written as base 10. Okay, and so that's what they mean when they say write something with a different base. Now you can see how that's done.